This video demonstrates how to run a Python script in SecureCRT. Although I'm demonstrating this with SecureCRT version 9.7, the same general concepts would typically apply to other versions of SecureCRT. As an example for this video, I'll be using a Python script that backs up SecureCRT's configuration to an XML file named with the current date and time, as well as the version of SecureCRT, so you can easily see this information at a glance by just looking at the file name itself. If you want to get the example script so you can follow along, navigate to the vandyke.com website, go to the support section, scroll down to the automation and scripting section, and click the Advanced Python and VBScript Examples link. Navigate to the Backup SecureCRT's configuration to an XML file link, and scroll down to the bottom of the page to access the script file for download. I've downloaded the script file from the website and saved it to my Downloads folder. To run this script in SecureCRT, I'm going to open up the script menu and choose Run, navigate to my Downloads folder, select the script file, and press the Open button to run it. On some machines, you might already have a compatible Python scripting engine installed. However, on most machines, like the one I'm using here, there isn't a compatible Python scripting engine available by default. So trying to run a Python script in SecureCRT would likely result in an error such as the one you see here. This error message not only tells me that SecureCRT cannot find a compatible Python scripting engine on my system, but it also tells me how to fix the issue by installing a supported version of Python from python.org. The version of SecureCRT you are running might be different, but in this particular version of SecureCRT, the message reveals that Python versions 3.14, 3.13, 3.12, 3.11, and 3.10 are supported. In most cases, I'll simply want to install the newest version listed here that is also available for download from python.org. I'm going to use this information to download a compatible Python installer from python.org. On the python.org website, I click the Downloads link and scan for an installer for the newest version matching what was listed in the error message in SecureCRT. Depending on the version of SecureCRT you're using, you may need to scroll down quite a bit to find an installer for earlier versions of Python. In my case, Python 3.14 is the most recent version on python.org, and it also happens to be listed as supported by SecureCRT version 9.7, so that's the version I want. I'm on a 64-bit version of SecureCRT, so I'll download the 64-bit Python installer. Now that the download has completed, I'll launch the installer. For the most part, I should be able to accept the default options presented by the installation wizard. However, SecureCRT will need to find the Python libraries in the system path environment variable, so I'll want to make sure to enable the add python.exe to path option in the installer. At the end of the installer, there's another option I may see about disabling a maximum path limit in Windows. It's irrelevant in my case, so I'm just going to skip over it. Now that I've installed Python, I'm going to try to run the backup config example script again, but I'm still seeing the same error that I saw before installing Python. The problem is that this instance of SecureCRT was running before Python was installed, so I'll simply close SecureCRT and start a fresh instance, which will inherit the updated path environment variable, and sure enough, when I attempt to run the same script, that pesky Python engine problem that was previously portrayed is no longer present. As the example backup config script runs, it displays information about the export operation in progress, including the path where it's being saved to, and I can see the file name has SecureCRT's version and the exact date and time at which the export operation was initiated. When the export operation completes, the script displays a backup operation completed message, and I am instructed to press any key to close the tab and the script will exit. Looking in my Documents folder, I can see that the backup XML file was generated as expected, and expanding the width of the name field with a double-click operation on the column header's divider bar allows me to see the full file name. In SecureCRT on the macOS platform, the process is similar. If I try to run the backup config script before installing a compatible Python 3 scripting engine, I'll see an error similar to what I saw on the Windows platform. Again, the text of that error message tells me which compatible versions of Python SecureCRT would be looking to load but couldn't find in the expected locations. So I'll go to the python.org website, locate the universal installer for a compatible version of Python, and download it. Once the download has completed, I'll simply move forward with installing it, and I'll accept all of the default settings. Once a compatible version of Python is installed, I'll still see an error if I attempt to run a Python script in an instance of SecureCRT that was still running before I installed Python. SecureCRT only attempts to load the Python scripting engine when the app is started, so I'll just need to make sure I completely exit SecureCRT via its main menu, or use the macOS standard Command Q keyboard shortcut, and then start a fresh instance of SecureCRT. And once I've started a fresh instance of SecureCRT, I'll open the script menu and trigger the recent backup config script, and I can see that it's now running without issue in SecureCRT on my macOS machine. When it comes to SecureCRT on the Ubuntu platform, only the Ubuntu LTS releases specifically listed on our website are supported. These Ubuntu LTS releases have a built-in Python engine which SecureCRT is hard-coded to use. This means that on supported Ubuntu platforms, there's no need to install any external Python scripting engine. Here on my Ubuntu 24.04 machine, I've downloaded the same backup script file to my downloads folder, and I'll open SecureCRT, click on Script, Run, select the script file, and run it. As you can see, the script ran without needing to install any external Python scripting engine at all. As a final note, you can also map a button to run a script rather than going to the script menu in SecureCRT and choosing Run. This is especially helpful with this particular example because mapping it to a button allows you to create a backup of your entire SecureCRT configuration on demand with merely a click. That's all for this video showing how to configure your system to support running Python scripts within SecureCRT. As always, stay secure, my friends.